Hello, in previous video we saw a concept of average and central tendency. Let's have a quick revision. Averages are tools of summarizing data, finding representative or a single value. So what is central tendency? Most of the observations are clustered in central part of the data, and if we select representative observation from the central part, then it is referred to as an average or measures of central tendency. For example, average marks, average income, etc. In previous lecture, we have discussed objectives and requisites of averages in details. If you have missed the session, kindly go through the link given in description box. So let's start with today's lecture. In this video, we are going to see the first measure of central tendency, that is arithmetic mean. We are going to see the examples and concept of arithmetic mean for individual observations or ungrouped data, discrete frequency distribution, and continuous frequency distribution. So what is mean by arithmetic mean? This is the just traditional definition that arithmetic mean or mean is sum of observations divided by total number of observations. Let's see how to calculate arithmetic mean for individual observations or ungrouped data. Suppose x1, x2, x3 up to xn is a set of n number of observations, then arithmetic mean is equal to, arithmetic mean is also denoted by x bar, which is equal to sum of all observations, that is x1, x2, x3 up to xn divided by total number of observations, that is n. We can write this formula in this way also, that is summation of xi divided by n. This sigma sign stands for summation, and I is varying from 1 to n because we have given n number of observation. If I is equal to 1, then xi stands for x1. If I is equal to 2, then xi stands for x2. If I is equal to similarly n, then xi stands for n. So this is nothing but summation of I is equal to 1 to n xi, that is sum of all observations. So let's solve example for individual data or ungrouped data. This is the individual type of observations or ungrouped data. That is, frequencies are not associated with any values. These are the isolated values. Therefore, we call them as individual observations or ungrouped data. Let's calculate arithmetic mean for this data. So what is the formula for arithmetic mean? That is, as we have seen, summation of xi upon total number of observation. So sum of observation is nothing but we are going to add all the observations, that is 81 plus 49 plus 52 up to 61, and the total number of observation is 1, 2, 3, 4, 5, 6, 7. So n is equal to 7, that is total number of observation. So sum of all these observation is nothing but 450 divided by 7, and we got the answer is 64.285,714. Try to write the answer up to 6 decimals after decimal points in order to get the closest value. So the arithmetic mean for this data is nothing but 64.2857 285714. So now the second type is arithmetic mean for discrete frequency distribution. Suppose x1, x2, x3 up to xn are the values with corresponding frequencies f1, f2, f3 up to fn, then arithmetic mean is x bar is equal to x1 f1 plus x2 f2 plus x3 f3 up to xn fn divided by total number of observation, that is all frequencies, that is f1 plus f2 plus f3 up to fn. So we can write this formula also, summation I varies from 1 to n, as we have given n number of observations, xi fi, because the observations are varying from 1 to n. So we have given here I is varying from 1 to n, divided by total number of observations, that is summation of I varies from 1 to n fi. We can write summation of fi I varying from 1 to n also as capital N. So let's solve the example of arithmetic mean for the discrete frequency distribution. Why it is discrete frequency distribution? Because these are the frequencies. Frequencies are associated with discrete value or single value. Therefore, this type of data is discrete frequency distribution. And how will we read this data? Xi's are along with their corresponding frequencies. That is, x1 is with frequency f1, x2 with his frequency f2, x3 with frequency f3, and so on. That is, we are repeating x1, that is 3, for f1 times, that is 2. In simple word, we are taking 3 for 2 times, we are taking observation 10 for 8 times, we are taking 18 for 9 times, and so on. So let's solve this example. So arithmetic mean formula is x bar is equal to summation of xi fi divided by summation of fi. So to find the value of summation of xi fi, we need to make the another column, that is xi fi xi or xi fi. These are the values of nothing but xi, these are the values of nothing but fi. So we need to do the multiplication of these first two columns. So first observation of xi fi, that is x1 f1 is equal to 6. Next is 80. Then 18 into 9 is nothing but 162. Then 165. Then 6. Okay. So we need to find the summation of xi fi. So we need to find the total of this column, that is nothing but 419. We need to find the summation of fi, that is nothing but total number of frequencies. So the addition of summation of fi is nothing but 31. So let's make a division. 419 divided by 31. So we got the answer, that is 13.516129. So this is the arithmetic mean for this discrete type of frequency distribution. Now, next type is arithmetic mean for continuous frequency distribution. We have written the same formula like previous one, but here we have just replaced x1 by m1, x2 by m2, and mn, xn by mn. Why we have written like this? I will explain it using example. So this is the continuous type frequency distribution. So what is continuous frequency distribution? In previous type, frequencies were associated with single value, but in that type, frequencies are associated with entire class. That is, let's understand this line using example. So there are 5 students. So there are 5 students, 5 observation who are lying in the observation 0 to 20. There are 12 observations who are lying in the range 20 to 40. There are 30 observations who are lying in the range 40 to 60, and so on. So in the calculation part, since there is no any specific value in the column of xi, we make a reasonable assumption that the frequencies are associated with midpoint of a class. So taking m1, m2 up to mn as the mid values of a class intervals, we are going to calculate the mean. Hence, we have taken here m1, m2 up to mn instead of x1, x2 up to xn. This is the only difference between discrete frequency distribution and continuous frequency distribution. in the continuous frequency distribution, we take mid values instead of direct observation, that is xi's. So let's take the mid values first. We are going to make a column that is mi. So what is mid value of this? So mid value is nothing but lower limit plus upper limit divided by 2. So lower limit is 0 plus upper limit is 20 divided by 2, that is 10. In the same way, we are going to calculate all the mid values. So next mid value is nothing but 30, next is 50, 70 and then 90. If you see, the difference between 0 to 20 is 20. The same difference is lying in the M1, M2, M3 and so on. That is 10, 30, 50, 70, 90. Okay. So the formula for arithmetic mean for continuous frequency distribution is nothing but summation of fi mi divided by summation of fi. In order to find the value of summation of fi mi, we need to make another column, that is fi mi. Okay, so let's this is the nothing but column of fi. So we are going to multiply this column by this. So the multiplication is nothing but 5 into 10 is nothing but 50, 360, then 100, 1500, 1260, 810. So summation of fi mi. So we need to add this column. Summation of fi. So we need to add this column. So this addition is nothing but 3980 and summation of fi is nothing but 74. So let's make a division of these two numbers. So we got the answer 53.783783. So this is the arithmetic mean for this continuous frequency distribution. So in today's video, we saw that how to calculate arithmetic mean for different types of data using example with suitable formula. So if you have any doubts so far, comment me in the comment section. Thank you. And in next video, we are going to see the properties of arithmetic mean. Thank you and all the best.